Hi everyone, in this video we're going to be looking at changing the subject of a formula, and we're only going to be looking at intermediate examples. There's going to be another video for higher that you can access later on. So to start off with, we're going to look at one-step examples. That means we only have to complete or do or compute one operation before we get the final answer. So the first example we're going to look at is y plus w is equal to c. And for all the one-step examples that we're going to look at today, we're always going to look to make y the subject of the formula. Now at the moment, in this example, c is actually the subject, because c is a single term of c on its own equal to something else algebraic. So c is actually the subject of the formula at the minute, and we want to perform some algebraic manipulation so that y is the subject. So we have y is equal to, and then an algebraic terms or other terms on the other side of the equal sign. Before we go ahead and look at this, I'm just going to remind you of a question which may look something similar, and that is solving linear equations. So I'm going to write y plus 4 is equal to 21. Now, if we had to solve this equation, the first thing we would do is subtract 4 from both sides. We would use our inverse operation, and we would have the fact that y is equal to 17. Now, I'm not going to write 17. I'm going to write 21 take away 4. The reason being, we use this exact same method for changing subjects of formulas. We're just going to be left with algebraic terms as opposed to a final numerical definite answer. So this would be y is equal to 17. So applying this method to the example we've got here, in order to make y the subject of the formula, we're essentially going to solve algebraically for y. So that would mean we subtract w from both sides using our inverse operation, which leaves me y is equal to c, take away w. So key things to get in our head is that we're using the same skills as when we solve linear equations. We're just doing we're going to have an algebraic answer as opposed to a final numerical answer. And we just need to be really comfortable and confident. And those are the skills we're going to develop throughout this video in our algebraic manipulation. So we're going to make y the subject of the formula here. So what manipulation do we need to do to the left-hand side? We need to add p if we were going to solve for y. Therefore, we need to add p onto the right-hand side of the equation to give me that y is equal to m add p, and we add then. So again, we're using the same skills as solving linear equations. We've done some algebraic manipulation and we solve for y. Okay, so we've got a lots of y is equal to w. So just a reminder here, this terminology means a lots of y, or a multiplied by y. And in order to solve for this equation for y, so if we had 4y was equal to w for our solving linear equations, we would divide both sides by 4. And the answer we would have is y is equal to w divided by 4. So this time we're going to divide both sides by a. And solving for y, we get that y is equal to w divided by a. So a similar example, this time we have 3 lots of y. So in order to solve for one lot of y, we would need to divide this side by 3. So we're going to divide this side by 3. Therefore, y is equal to c divided by 3. Or, I'm just going to write this here. You may see it written slightly differently as 1/3 c. Those two things, c over 3 and 1/3 c, are exactly the same thing mathematically. So this time, again, we've got some algebraic notation we may need to remind ourselves of. This means y divided by c, or y split into c amount of groups. Therefore, to solve for y, we're going to multiply both sides by c, and therefore y is equal to, now I'm going to write this as w times c, but I would want you to become more confident in writing it as CW, because remember in algebra when we have terms written next to each other, that implies that they are being multiplied, and we write them in alphabetical order. Now we've introduced a power, so we've got y squared is equal to s. There is no need to think that this is any harder than anything you've just done. You just need to be really secure with your inverse operations. So the inverse operation of squaring something is to square root it. Therefore, I'm just going to apply the square root to both sides. So I go y is equal to the square root of s, and I've solved for y. I've made y the subject of this formula. Here we have 4 pi y is equal to b. Now we need to remember that pi is actually a number, okay? We call it a constant in maths because it is represented by the same number. So pi is a constant that is 3.14 and so on. So this number here, 4 pi, is just going to be 4 lots of a number. Therefore, what we've actually got here is 4 pi times by y. So we're doing 4 pi lots of y. In order for us to do an inverse operation here, we are going to divide by 4 pi. So I've solved for y, and b is being divided by 4 pi. So please don't be put off by when they introduce pi. You need to think of it as a constant, which in realistic terms means we treat it the same as if it was a number. So we can divide by 4 pi, and therefore we end up with a solution y is equal to b divided by 4 pi for this example. Okay, again, we've got a power involved, so we just need to remember that we take the root. So because we're squaring, we're taking the square root. If we were cubing, we take the cube root. So we're going to take the square root. So this gives me y is equal to... Now, because I have two terms here, I need to ensure that the square root encompasses everything on that right-hand side. So y is equal to the square root of k plus x. Okay, moving on then, we're going to look at some two-step examples now, and this is where we have equations similar to our level 1 equations that we call them in class, our linear equations. So we just need to do an extra step of algebraic manipulation. So throughout these examples, we're going to make x the subject of the formula, or we're going to solve for x. And just like with linear equations, that means we're going to look to isolate the term involving x first, and then do any manipulation we need to from there. So for this example, the first thing we would do is subtract c from both sides. This would leave me with 4x is equal to w take away c. From that point on then, if I've got 4 lots of x, I need to divide by 4. So that will leave me with x is equal to w take away c all divided by 4. So to remember that you write that this is all divided by 4 on here when you write your final answer, otherwise you get incorrect. But we're following the same process as the one step in terms of our algebraic manipulation, solving for x. There is, as the name just suggests, just an extra step involved. So we've got dx take away t is equal to 8. So the first thing we would do here is we're going to add t to both sides to leave me with dx is equal to 8 plus t. We're then going to divide by d to leave me with 8 plus t divided by d. So we've got a power here, so we need to know we're going to be rooting if we can see a power on our subject that we want. In this case, we've got x squared. So I would subtract 3 from both sides initially to leave me with x squared is equal to h take away 3. And then I would need to square root both sides of my equation to leave me with x is equal to the square root of h take away 3. So we're going to look at a couple of examples involving fractions now. The process still stands though. We want to isolate the term involving x ideally if we can, and then cope with that. So the first thing we would do is subtract 2 from both sides. This is going to leave me with x divided by n is equal to w, take away 2. So as we've said previously, this means x divided by n. Therefore, we're going to multiply both sides by n. So this would leave me with x is equal to, now this is an important bit here. We want to multiply all of w take away 2 by n. The best way to write this mathematically is to say n lots of w take away 2. So we can write it as n would be a factor of both of these terms, so we're going to write it as a common factor in terms of brackets. A slightly different fractions example here. The difference being we have all x involved in the numerator of the fraction this time. So if I was to write this similarly to the last question, then you can see the difference where we had x involved in a fraction and a second term. This time we only have a fraction on the left hand side of the equation, or on one side of the equation. So the first thing we would do in this instance is multiply both sides by c. Therefore we have x plus 3 is equal to ch. And now we can subtract 3 from both sides to leave me with x is equal to ch take away 3. And again, from our examples with one step, we recognize that pi is just a constant, it is just a number. Therefore, the first thing I'm going to do is divide both sides by pi to leave me with a divided by pi is equal to x squared. And we've got a power of 2, so therefore we would now need to square root both sides. And again, important when you're writing your answer, all of a divided by pi has to be involved in my square root. So we're going to write it like that, is equal to x. Okay, so we can identify the x in this term here. So we're going to follow our same rules of manipulation. Yes, it looks slightly more difficult, but if you simplify it to I need to solve x, so I'm going to do inverse operations, then we'd be more than comfortable in approaching these style of questions. So the first thing I'm going to do is subtract u squared from both sides. So that gives me v squared take away u squared is equal to 2ax. Now, much like in examples where we had 4 pi x, 2a is just going to be a constant as well. It's going to be two lots of a number, which is going to always equal to another number. Therefore, we can divide by 2a here and leave me with v squared take away u squared divided by 2a is equal to x. So again, something which looks a little bit more difficult, but if we continue with our simplistic method of using inverses, we end up with an answer which we should be more than capable of getting. So this time we have x in the denominator of the fraction. Now the first thing that we want to do is to manipulate this so that it's not involved in the denominator. So that means we're going to multiply both sides by x to leave me with a plus b is equal to r times x. Now in order to make x the subject of the formula now, we would divide both sides by r to leave me with all of a plus b divided by r is equal to x. And on to our final example. This time we have a root happening first, and the opposite of a root is to take it to a power of. So the first thing we are going to do is cube both sides, because we've got a cube root. If we had the square root, we would square both sides and so on. So this leaves me with x divided by k is equal to w cubed. And now the next manipulation is going to be to multiply both sides by k. Therefore, solving for x, we get this would be kw cubed. So again, we've got a slightly different looking question there, but we remember our inverse operations, and then we just follow through with a proper algebraic manipulation in order to solve or make x the subject of the formula.